Hello guys, first we will see the what is the learning outcome of the today's lecture. Right, in this today's lecture what we are going to do is we are going to know the what is called as the don't care combination, how which are going to be applicable into the K-map, right? So what is the useful of don't care combination, so how to represent the don't care combination in K-map, right? So these things we are going to see first. So later on we are going to see what will be happen if you are minimizing the expression without don't care combination, and one more thing, with don't care combination if you are going to perform the minimization, then what is the difference we are going to observe in this today's class. Right, before going to solve the problems, right, by using of the don't care combinations in the K-map, first we will try to understand what is the meaning of the don't care combinations. Right, so if you read these statements, right, the don't care combinations are used in the K-map. Just remember like this in order to produce the simplest output expression. Right, once we try to solve the problem, we will understand how it will produce the simplest output expression. Right, so far what we have seen is, right, in K-map either we have the SOP function as well as the POS function, right? SOP means representation of the 1, POS means representation of the 0, that we know that, right? Suppose for example if this particular set, it may be SOP, right, it may be POS, something like this, right? So these kind of things we have seen in so far in the K-map. Right, now one more new term is added, so that is called as the don't care combinations in the K-map. Right, so what is the use of don't care combination in the K-map? If you don't know, for example, particular value, either it may be 1 or it may be 0, you might be having the dilemma that whether you need to consider the output as 1 or output as 0. In this case we will be having the something called as the don't care representation. Right, means that if you don't know whether that particular value is 1 or representation of the 0, then it is we are going to represent with the don't care combination. Then how don't care combination will be represented, that is one more point. See, if it is SOP we is to represent 1, right? If it is POS we is to represent with 0, right? So how to represent the don't care means by using of cross we are going to represent the don't care thing. This is a one more new term added to the minimization of the K-map, right? So here it is represented with the something like this symbol. Some people they used to write don't care instead of writing this cross, they used to write ding, right? That is also correct representation only, right? So according to your requirement, either you can consider this one or this one, right? So will be same. Now we will see that. So don't care, so if you read this statement you will understand don't care cell we can consider either 0 or 1, and if required we can also ignore that cell. So what is the meaning of this one is, when you are going to, right, so try to understand this point guys. So we are going to perform the minimization operation in K-map, right? So what is the meaning of the minimization? To reduce the smaller number of components from the larger number of components, right? If you are using the don't care combination, remember that if it is useful, right, if it is useful for what? If it is useful for minimization, then we need to consider it as the 1. If it is not useful, means if you feel that the don't care combination will not be useful, then you omit it, right? Again I'm trying to repeat guys. So what you have to do is, if it is helpful for minimization, then you consider the 1 in the SOP function, you treat it as the 1. So if it is 1 means, sorry, if it is don't care combination means if it is useful for you in terms of the minimization, then you consider as the 1, right? So like this we can consider. Suppose if you don't feel like that it will never useful for minimization in your K-map, then you leave it as it is. Remember 2 point, if it is useful you consider as the 1, if it is not useful you consider as the 0, sorry, you consider as the right neglected value, right? So this is in case of the SOP function, right? Now we will see the problem so that you will be having the clear cut of the idea regarding this, right? So for example, see that here I have taken the 3 inputs, right? So let it be, this is input values A, B, C. Let I'm going to take some random output value. That output is something 0, 1, 0. We'll consider like this guys, 0, 1, 0, 1, 0, 1. These are the either SOP function or POS function, right? Just I'm going to write the output as the cross or cross. So what is the meaning of cross here guys? Cross here means we don't know whether it may be, generally earlier we used to represent output either it may be 0 or 1, right? At this point of time we don't know what is this particular value, right? It means that x means single value, right? It means that single variable means either it may be 0 or it may be 1, right? If you don't know either it may be 0 or 1, then we are treating it as the don't care combination, right? Now what we have to do is, right, by default I told that representation of the output is nothing but the SOP, means representation of the output value equal to 1, I said, right? Now see that where we have the ones, right? So this location we have the 1, right? Just remember this is SOP function. Representation of 1 means SOP function, guys. For that only we are going to write the K-map minimization. If you want to take 0 also, then that is nothing but the representation of the POS function, right? So here we have the 1. Now you try to tell me whether we need to consider the this don't care, this don't care in K-map or not. I mean, can we take this as the SOP function? Yes or no? Think and tell me, guys, answer. See, what is the meaning of this don't care combination? Either it may be 0 or 1. If it is 0, it is okay. Then what is one more possibility? Either it may be 1 also, right? Right? If it is 1 means there may be two possibilities, right? It may be 0 or it may be 1. Suppose if it is 1, then what? It is SOP, right? We need to consider, right? So at this point of time, if you are solving for the SOP, we need to consider this also, because either it may be 0 or 1, we don't know, right? So for that reason, if it is don't care, we need to consider that also, right? Now for understanding, we will write, first we have to write the minterms, guys. So like this, we will write 0, 1, 2, 3, 4, 5, 6, 7. Now what is this value, right? What is this minterm value? This minterm value is the something 1, right? And here output is 1, right? SOP function. What is this input value? 0, 0, 1. 0, 0, 1 means 1 is the minterm value. Next, what is the second value? 3, right? Because this output is belongs to the input 3. Just we are writing the minterm means input value. 1, 3, what is this value? 5 is the value. 1, 3, 5, then these are the not SOP function, guys. This don't care are not the SOP function, right? So how you write like this means the direct ones we are representing with the 1, 3, 5. Now this cross also we need to consider, right? These crosses also we need to consider. Why we need to consider this cross? Because either we don't know, it may be 0 or 1, right? If it is 1, then we should consider, right? Because we are treating output as the 1 means SOP function, correct, guys? Right. Now these are the normal value, like this one 1. This one output is belongs to input 1, guys. So for that we need to write the minterm 1. Next, this is for 3, this is for 5. These terms also we need to include, but directly we are not going to include here, right? So how we are going to include here means these are the don't care combination, that is going to represent with the D of what is that value? This location is nothing but 6, right? 6 is the 1 value. Next, what is this location? 7 is the 1 value, right? So this is the something question like this. This is only example truth table, right? Truth table, guys. There is no relation between input to the output. Just remember, I take some random output, right? For that, I am going to explain what will be happen without don't care combination and what will be happen with don't care with don't care combination. For analysis purpose only I have taken this table, right? Now we will solve the problem if without truth table as well as without don't care combination as well as the with don't care combination, right? Now see that first we will solve the problem without don't care, right? So here I am not considering, I am going to solve the problem without don't care operation, right? So without don't care operation means we are not treating the solving the problem in terms of the don't care, right? Next we will solve the problem in terms of the, here we will solve the in terms of the with don't care operations. Now we will see the difference. What is the disadvantage of this one? What is the advantage of this one, right? This is what I am trying to explain in this today's class, guys, right? First we will solve it without don't care combination, but we will plot the don't care combination. We will not see that how to minimize by using the don't care combination. What is the given product term value, right? Minterm value 1, 3, 5, right? 1, 3, 5, guys, right? Next, what is the don't care combination? In which location? 6 and 7, guys. 6, 7 is the location, right? Now feel that you don't know anything about this one, you leave it as it is. As we know that if it is useful in SOP, consider as the 1. If you don't know, then you leave it as it is. Don't do anything. whatever the operation you know previously, the same thing you perform, right? Understand guys? Done. Now without using the don't care, I'm going to performing, right? These three ones are there. Now what is the group you will be getting, the guys? You will be getting the group is something like this group, right? What is the answer for this group? A bar into, final right answer here, A bar into, because this belongs to completely A bar, right? So here it is belongs to B bar get cancelled, C means C. So what is the product term value here? A bar C. Next, what is the one more possibility, guys? This we can group, right? So what is the answer? Plus B bar C is the answer. See, just look at this expression, guys. So for this we required one AND gate. For this we required one more AND gate. In order to perform OR gate operation, we required the three logic gates. At what case, guys? Without using the don't care combination. Now, see, just remember that for doing this, we required the three logic gates to implement this K-map without using the don't care combination. Now, what we will see is, in order to understand what is the use of don't care combination, right, as we said earlier in the previous slide, the don't care combination which are used to produce the simplest output expression. Without using the don't care means we got the three logic gates. Now we will try to see, right? So first, what is the given? Again, this we have to plot, right? 1, what is that value? 1 comma, next 3 comma 5, guys. What is the don't care combination? 6 and 7, just represent with the cross mark, right? Now what is the procedure generally we used to do, guys? If it is 3 variable K-map, maximum possibility will be 8 possibility. Now what is the first priority we need to give, guys? For grouping of the 8 ones, including don't care, you check is for example from here we will start, guys, right? We'll start from here. If we start from here, for this one, is there any 8 adjacent ones? No, right? In the K-map itself we don't have the 8 ones or 8 crosses, right, guys? So 8 is not possible. Then what is the next case we have to do? We need to group of the 4 ones. Check, guys, is there any 4 grouping possibility or not? Try to understand, guys, is there any 4 possibility or not? As I said earlier, if it is useful, you consider as the 1. Means if it is useful in your minimization, you consider as the 1. If it is not useful, you consider as it is, means don't do anything. There are 2 options we have in SOP function. Now see that if you consider which don't care combination 1, you will be getting the 4 grouping, guys. Try to understand this logic. So if I treat this one as 1, now what will be happen, guys? If I treat this one, now what will be happen, guys? We can group the 4 ones, guys, right? We can group the 4 ones, right? Now what is the answer, right? So A bar, A will get cancelled, so B bar will get cancelled, C into C means C. Earlier we required 3 logic gates, guys. Now how many logic gates are we required? We don't require any logic gate. C means just a single variable, just we need to purchase the connecting wire. Now see that what is happening without don't care combination, what is happened with consideration of the don't care combination. Now some people will do such kind of mistake, right? What is that mistake is? So for example, see, some people what they will do is, this also they will consider something like this. This one is there, guys, right? So what they will do is, this will they will consider this also once. Now what will be happen, guys? Again one more group will come, right? So one more group means C plus, right? C plus some other product term will be coming, right? It means that again number of logic gates are increasing, right? So for that reason, whichever is the helpful, that only we need to consider the don't care combination. Here it is useful, guys, for us, so we are considering it as the 1. Here it is not useful, guys, so what we are doing here, just we are omitting as it is. We are not using in our minimization. So final thing is that what I am trying to say is, don't care combination which are used to produce the simplest output expression. If you feel that it will be useful in our solution for minimization in SOP function, you consider it as 1. If not useful, you just omit it, is right? Like that we need to do, right? We need to use the don't care combination. So in which case we use the don't care combination? If you don't know whether that particular output value, it may be 0 or it may be 1, in that case we use the don't care combination. So don't care combination means it is also some single variable, guys. So it means what is the input possibilities? Either it may be 0 or 1, right? Instead of writing, if you don't know either a POS function or SOP function, then we used to represent with the don't care. That's it, right? There is not great logic, guys, right? I hope you understand. So in next class what we will do is we will try to solve some more problem on the don't care combination, so that you will be getting the clear cut knowledge. Thank you guys.